The end of the chapter.
Like 3 hours. I got that already. Was that Saturday? Yeah. That's supposed to be 3%. I got it already.
Josh, where's my eraser?
Okay, now we're finally switching to proportions. So we had 3 sections where we were doing the difference in means. We had big sample with independent, small sample with independent, and then we did dependent, where it was the same group, like a before and after. Now we're doing the difference in proportions. Okay, here, so I should say P1 minus P2, difference. We're testing the difference in the 2 samples. So first of all, the samples must be independent, so there's no overlap. You can't have the same person in the first sample and the second sample. So samples must be independent. And they have to be large enough to be normal. And it's not the magic number 30, that only works when you're dealing with means. I'll show you. There's a little check, we had it before. And the 2-part check is the sample size times the percent success has to be greater than or equal to 5. And the sample size times the percent failure also has to be greater than or equal to 5. So not only do you have to check that sample 1 is big enough, you have to check that sample 2 is big enough. So that the sample size times the percent success and sample size times percent failure. So all 4 of those have to work.
Just watch it. You're gonna have a question where 3 out of 4 of them are okay.
Nope. Okay. Your sample statistic is P bar. And that's the percent successes from the 2 samples together. So you take the number of successes from sample 1, add it to the number of successes from sample 2, and then the 2 sample sizes added together. So you get 1 big percent. So P bar tells you you're averaging, so it's the total sample sizes over the total successes. And then we've got to turn this into a z-score. So the z-score for P bar. Oh, not P bar. I lied. Not for P bar, it's for P hat 1 minus P hat 2. Is P hat 1 minus P hat 2 P bar, Q bar, 1 over N1 plus 1 over N2.
Why do you always have to subtract?
I don't make the rules. Okay, you ready for your example?
No. I think we can go right to the worksheet.
Pass the book. I'm only going to do 1 example. It's pretty quick.
So, I don't know if you
Are we good?
Yeah.
Okay, here we go. Claim. The proportion of Vietnam vets suffering from alcohol abuse
What a great problem to start on.
I know is greater than the proportion of non-Vietnam vets suffering from alcohol abuse. Oh, not if you write small enough. Oh, then, yeah.
Is that just Vietnam vets?
Yep. Okay, we're going to test this at 5%. And here's our data. They did a survey of 7,924 Vietnam vets and have found that 1,085 are suffering from alcohol abuse. The non-Vietnam vets, sample size was 7,364 and 678 suffering from alcohol abuse. So is that difference significant, is what you're looking for. You can definitely see they're different. Is it significant?
I think it's just
With that change,
Okay, we need to check that the sample sizes are large enough. So check for normal.
I feel like that.
Yeah, they look quite large. So it's sample size times the percent of success, and success is suffering from alcohol abuse, bad thing, but that's what we're looking at, so that's falling into our success category. Our percent would be these two divided. Remember, when we're doing that multiplication, we're really just ending up with the number of successes. So is that over 5? Yes. So are all of them going to be over 5?
Yeah.
So they're all good. So all we're going to say is all good. We're not going to take the time to do all 4 of those. So just telling me that you checked them is enough for me to give you your point on the test. Just remember to do that for this section with proportion. Okay, so rewriting the claim. So what it's saying is the proportion, so we're not using means, we're using P, of Vietnam vets suffering from alcohol abuse is greater than the proportion of Vietnam, or non-Vietnam. So P for Vietnam is greater than the P for the non-Vietnam. So if we write that as a difference, we want to write it as a subtraction, just like we have in all chapter. Our claim gets rewritten as is greater than 0. Making the claim the hot. The whole. They were large enough to be normal. We're using z-scores. Z-scores when it's large enough. So notice this chapter, there's no chi table. It's just z and t. And the only section we did the t on was the dependent one. Oh, no, I lied, small sample too, so 2 out of 4, I lied. So half the chapter was Z, half the chapter was T. So we are doing a right tail test because Ha has a greater than. 5%. Z score. Anybody have this Z score?
2.575.
I don't have that written down. Unless somebody fed me the wrong answer last year.
Negative 1.645.
How about positive 1.645?
Plus or minus 1.645.
So I'm on the positive side.
Look at it. Oh my goodness.
Try again.
I was looking at 0.
Okay. Okay, we need our P bar value so that we can plug it into our Z score. So off to the side, let's find P bar. So that we can plug in here and then Q bar. Alright. So P bar is going to be the number of successes added together from both sample sizes. So that's 1,085 plus 678 over the 2 sample sizes added together. And if you want to go with a decimal here, that'd be fine. Let's go 3 places on the decimal. It'll make your life a little easier to go into decimals and keep them in fractions. 115. Okay. So now the P hat 1 we're going to need. That's our percent successes from our first sample. So if I look back, that was 1,085 out of 7,924. And P hat 2 is the successes from sample 2. So if you want to do decimals there, you can. If you want to go with keep them as fractions, you can. I don't really care. What do you want? Decimal? Okay, what's the decimal for the first one? And the second one? Okay, we're going to need Q bar too. How do you get Q bar if you know P bar? Subtract from 1. That's going to give us what? 885. Okay, we've got everything we need to plug into that Z-score formula now. So the Z-score for P hat 1 minus P hat 2. Yep. So everything's here that we need. The formula says subtract your P hat, 0.137 minus 0.092. Then the difference in the whole is a 0. The denominator is P bar times Q bar. And then times the quantity, 1 over each sample size. I do have a final answer this time. Nope.
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 8.71?
Yeah, I got.
Yep, I got 8.68, but I'm gonna say yes.
Good, Tori. I got it right.
So what is that telling us to do? Reject the hoe. Claim is true.
Homework.
Okay, finish the chapter.
Wait, I wanna try this.
All right, you try it again. I'll come and help you if you need help. Page 404. Even, 8 through 16 even. Just, I think that makes what, 5 of these?
Are they up?
Yeah, 5 of them. And James, there's a half hour left if you want help today. Today's a good day.